Hello students, in lecture number 14, the class of statistics. In this video lecture, we will learn the testing of hypothesis for difference between two population means using t-test. इससे पहले we have done the testing of hypothesis for difference between two population means using z-test. Z-test तब हम use करते हैं when population standard deviation is known and sample size is greater than 30. But when the sample size is less than 30, or if we are dealing with two populations and if we draw samples from those two populations with sample size less than 30, in that case also we use t-test, provided population standard deviation also not known here. We use t-test under the following assumptions. These assumptions are not given in the questions particularly, but we have to take them in advance to solve the problem. First is population from which samples have been drawn are normally distributed. Population variances are unknown and are equal. Two samples are random and independent of each other. ये जो assumptions हैं ये क्वेश्चन में स्पेसिफिकली मेंशन नहीं होती हैं, लेकिन टी टेस्ट अप्लाई करने के लिए हम ये एज्यूम करके चलते हैं कि these conditions are satisfied. So here we consider two populations and hypothesis is about their means. यहाँ पर दो populations हम consider करेंगे जिन जो hypothesis है that hypothesis is about their means. Samples are small in size, that is less than 30. So let's see what are the steps of hypothesis testing. Step number 1 is state null hypothesis H naught, which is mu1 is equal to mu2. Mu1 is the mean of the first population and mu2 is the mean of second population. And null hypothesis that mu1 is equal to mu2 means there is no difference in their population means. State alternative hypothesis, that is mu1 is not equal to mu2 or mu1 is greater than mu2 or mu1 is less than mu2. So which alternate hypothesis we state, that depends upon what type of claim we want to test. Step number 3 is set level of significance alpha. Step number 4 is compute the value of test statistics. Here we use the test statistics as T, which is given as x bar minus y bar minus mu1 minus mu2 whole upon s into square root of 1 upon n1 plus 1 upon n2. This statistics follows T distribution with n1 plus n2 minus 2 degrees of freedom, where x bar is the mean of the sample which is drawn from the first population, y bar is mean of the second sample which is drawn from the second population, s square is the common population variance which is obtained by sample information, that is 1 upon n1 plus n2 minus 2 into summation xi minus x bar whole square plus summation yj minus y bar whole square. सैंपल की इंफॉर्मेशन से हम पॉपुलेशन वेरिएंस का एस्टिमेटर कैलकुलेट कर रहे हैं. दिस इज ट्रीटेड एज अनबायस्ड एस्टिमेटर ऑफ कॉमन पॉपुलेशन वेरिएंस सिग्मा स्क्वायर. Next step is find critical value using alpha level of significance and degree of freedom is equal to n1 plus n2 minus 2. We use T table here and also mark critical and acceptance region. Step number 6 is compare the computed value of T with that of critical value and check that if computed value falls in critical region, then null hypothesis is rejected, otherwise accepted. These steps are very straightforward. Let's see quickly one example. The height of 6 randomly selected sailors are 63, 65, 68, 69, 71 and 72 in inches. Those of 10 randomly selected soldiers are 61, 62, 65, 66, 69, 69, 70, 71, 72 and 73. discuss the light that these data throw on the suggestion that sailors are on the average taller than soldiers. Here we have two populations. One population is the population of sailors and second is the population of soldiers. From first population, 6 randomly sailors are selected, and from second population, 10 randomly soldiers are selected. So obviously the sample size is less than 30 here. Nothing is known about the population standard deviation, and their heights are noted. So from the samples, it seems that the height of sailors is greater than the height of soldiers. So we want to test this claim that whether our suggestion is correct or not. So we set the null hypothesis. First of all, we make the following assumptions before applying t-test. First is population variances are equal. Population of sailors and soldiers is normally distributed. So step number 1 is mu1 is equal to mu2. Mu1 is the mean height of the population of sailors and mu2 is the mean height of population of soldiers. So null hypothesis state that there is no difference in the average height of sailors and soldiers. Step number 2 is because we want to test the claim that average height of sailors is greater than average height of soldiers. So we put here mu1 is greater than mu2. Alpha is equal to 5%. Step number 4 is value of test statistics, but to compute this we need S square. So first of all we calculate S square. So let us look at the formula of S square. What we need sum of the squares of the deviations of xi from their mean and sum of the squares of the deviations of yj's from their mean. So what we do here, we have listed here the values of x. X is used for sailors and their deviations are taken from their mean, which is 68 here, and then the squares of the deviations are calculated and their sum is obtained as 60. Similarly, for soldiers, the values are denoted by random variable y. Because average value is in decimal, so the deviations are taken from any one of the randomly selected values, which is 66 here. So d square is coming out to be 186. There is a relation between the sum of the squares of the deviations from mean and sum of the squares of the deviations from any arbitrary point. So this is equal to this. So we obtained sum of the squares of the deviations from their mean as 153.6. Summation d square we have obtained here, and summation d whole square is 18 whole square, just 324 divided by 10. Putting all the values, the value of S square is 15.25. So calculated value of t is coming out to be 0.099. Step number 5 is we mark acceptance region, critical region, and critical value, which is obtained from the table, because right side area, right tail area is 5%. Why we are using here right tail test? Because the alternative hypothesis is of the type mu1 is greater than mu2. So right tail area is 5%. So using this 5% area and degree of freedom is equal to 14. 14 is equal, 14 कैसे आया? It is n degree of freedom is equal to n1 plus n2 minus 2. So n1 is 6 and n2 is 10. So 16 minus 2 is 14. So degree of freedom is 14. So we look in the table for 14 degree of freedom and right tail area is equal to 5%. The value of t will comes out to be 1.76. So you can see that 0.099 is very much less than 1.76. So it falls in acceptance region. So null hypothesis is accepted. Null hypothesis is accepted means there is no difference in the average height of sailors and soldiers. The difference that is appearing here, it's due to by chance. Okay. So this is the numerical problem regarding testing of hypothesis for difference between two population means using t-test. Thank you very much. And if you liked my lecture, if you understood my lecture, like and share it and subscribe my channel to get more new videos on statistics. Thank you very much.